Welcome to Playback with another episode of History. Today, we're digging into the secret history of calculus. And believe me, it's a story that might just change the way you think about one of the most important moments in science. So, let me ask you a question right off the bat. Who really invented calculus? Now, if you're like most of us, you were probably taught that it was this epic showdown between two European geniuses, Isaac Newton and Gottfried Wilhelm Leibniz. You know, a classic story of rivalry and brilliance. But what if I told you that's not the whole story? What if it's not even close? Okay, so let's start with that official story. Picture it. We're in the late 1600s. The world of European math is absolutely buzzing. Everyone knows they're on the edge of something huge, a breakthrough that's going to change, well, everything. And two men are about to step into the spotlight. On one side, you've got Isaac Newton over in England. He's coming at it from a physics angle, trying to describe motion. And he develops what he calls the method of fluctuations. Then, over in Germany, you have Gottfried Wilhelm Leibniz. He's a philosopher thinking about logic, and he creates this incredibly elegant symbolic system that, we actually still use today. Their fight over who got there first became one of the biggest, most bitter feuds in the history of science. And right there, that's where our story takes a massive plot twist. Because what if the fundamental ideas they were both working with weren't new at all? What if they'd been discovered centuries earlier, thousands of miles away? This is what brings us to the real heart of our story. We're going to have to go back in time, way back, and travel across the globe to the southwest coast of India, to a place called the Kerala School of Astronomy and Mathematics, long before Newton was even a thought. Now, just look at this timeline for a second. It's kind of wild. Around the 1400s, a brilliant mathematician named Madhava of Sangamagrama and his followers figure out some of the absolute key building blocks of calculus. And then, look at that gap. We're talking more than 250 years of silence before their work is rediscovered in Europe by guys like James Gregory and Leibniz himself. That's a huge gap. So what was this revolutionary idea they discovered? Well, at its core, it's something called the infinite series. It's basically a clever way to find a perfectly precise answer by adding up an infinite number of smaller and smaller parts. And let me be clear, this concept is the absolute bedrock that the entire house of calculus is built on. And this right here is the smoking gun, mathematically speaking. This exact elegant formula for the arctangent function. It shows up in Caroline manuscripts in the 15th century. But in Europe, it doesn't appear until the 1670s, where it gets named the Gregory-Leibniz series. The math is identical. There's just no debate about who had it first. The Kerala school did. This, of course, raises a huge question. Was this all just one of the biggest coincidences in history? Or did the knowledge actually travel? This is where we get to put on our detective hats and investigate what historians call the transmission hypothesis. The theory is pretty compelling, and it goes something like this. Step 1. Indian mathematicians who need super precise calculations for astronomy make these incredible breakthroughs. Step 2. European Jesuit missionaries start showing up in Kerala. Now, they also need better astronomical data for their own reasons, like navigation and fixing the calendar. So, step 3, they start sending detailed reports back home to Rome. It seems totally plausible that, along with the raw data, the mathematical methods used to get that data could have trickled back and started to spread through the European academic world. But, and you knew there was a but coming, right? A plausible theory is not the same thing as hard proof. So now we have to be good historians, play devil's advocate, and look at the case for independent invention. So let's lay it all out. In the for column, you have the fact that the Jesuits were there, they needed the data, and the math is just so strikingly similar. But in the against column, there's a big one. There is no direct smoking gun. No historian has ever found a letter, a translated text, anything that says, hey, I learned this amazing math from my contacts in India. It's just not there. And here's another really critical piece of the puzzle. You have to look at why they were doing the math in the first place. The Kerala school's goal was very practical. They needed to create super accurate tables for astronomy. It was computational. Newton and Leibniz, though, they were after something much bigger. They wanted a grand, overarching theory to explain change itself, a whole new system of thought. Their entire approach and their goals were just fundamentally different. So you could say the Indians discovered the powerful ingredients, but it was Newton and Leibniz who wrote the cookbook. Based on all the evidence we have right now, The general consensus among historians is that while the Kerala school was, without a doubt, first to discover these key infinite series, it's very likely that Newton and Leibniz built their complete systems of calculus on their own. And what this does is it shifts our whole perspective. Maybe the question isn't just a simple who was first. Maybe the more interesting question is, what does this tell us about how science and big ideas actually come to be? There's a really great concept that helps explain this, borrowed from biology actually. It's called convergent evolution. You know, it's like how bats and birds both evolved wings independently to solve the problem of flight. Well, it seems that different human cultures can do the same thing. They can independently come up with similar mathematical ideas to solve similar big problems, like tracking the stars. All right, so let's wrap this up. What are the big takeaways? First, the fact that the Kerala school was centuries ahead on the key ingredients of calculus is indisputable, fact. Second, Newton and Leibniz probably did develop the whole system of calculus on their own. And third, and this is maybe the most important point, the history of science isn't some straight line from ancient Greece to Renaissance Europe. It's a rich, complex global tapestry with brilliant people making incredible discoveries all over the world, all throughout history. It really makes you wonder, doesn't it? If the story of something as fundamental as calculus is this much more complex and global than we were taught, what other hidden histories are out there, just waiting for us to find them? Thanks for joining us as we explored this amazing hidden chapter in the history of math. I hope you enjoyed it, and I really hope to see you next time as we keep digging into the fascinating corners of our shared past.